Hello geometry students, and welcome to a video part 2 on reflections in the coordinate plane. So this is our first video, our first lesson on transformations, and the first transformation is reflections. Alright, we've talked about the first two of what I call the big four reflections, and one of them is over the x-axis, and we have this rule over the x-axis where if you look carefully you can see that any point that you move over the x-axis and reflect it over the x-axis, the x-coordinates stay the same and the y-coordinates turn to the exact opposite. And anything that goes over the y-axis, it's the opposite that's true. The x's are the opposite while the y's stay the same. Alright, now we're going to see the next of the big four, which is here, graphing something over the line y equals x. So let's take a look at this one, and what I'm going to do this time is I'm going to do the same thing as we've done the others. I'm going to plot these 3 points that are going to make a triangle, and I'm also going to highlight the line of reflection, which is the line y equals x. The line y equals x has points like 1, 1, 2, 2, 3, 3, etc. Alright, so pause it, and you do the same thing. Okay, so there's the triangle XYZ, there's the line y equals x, and you can always graph this line by just, as long as the grid is a perfectly square grid, you can just look at this point in the corner, this origin, and this point in the corner, and if you connect those 3 points, you're going to get a nice straight line that's the right line y equals x. That only works if it's a perfectly square grid that you're looking at, which these all are. Okay, so let's look at our reflection. So we have to be really careful here. We want to reflect these points over the line. So this is a visual process for now, but it's going to be handy to have a rule here. So this point, negative 1, 1, is going to go to 1, negative 1. As you hear me say it, you're probably going to be thinking about the rule a little bit too, and it will make sense. Okay, this point, negative 3, 4, is going to go to 4, negative 3. So 1, 2, 3, 4, 1, 2, 3, right there. And this point, negative 5, negative 2, is going to go to 2, negative, wait, it's going to go to negative 2, negative 5. 1, 2, 3, 4, 5, right there. Does that look right? It should. Okay, each one of these, if you, here, I'm going to first connect them and we'll look at them for a second. Make sure that this is z prime. Make sure they look like the reflection. This is y prime, and this one over here is x prime. Let's connect them so that we can get that really clear idea of whether or not our triangles look like they're in fact reflections over that line. And sometimes it helps to zoom out, but they look pretty good. And what was I going to say? Notice that if I were to draw a reflecting line, a line that connects, now I'm just going to sketch it here so you can see. If I'm going to draw a line that connects the pre-image to the image, what I notice here is that the line of reflection is the perpendicular bisector of that segment. And that happens every time, by the way. And that happens for every single reflection that you'll ever make. And I'm just giving you a little preview because pretty soon we're going to be doing this without the coordinate plane. And this is all we have to rely on, is the fact that that line of symmetry is the perpendicular bisector. Each one of these lines that connects the pre-image point with the image point is perpendicular to the line of symmetry. And not only that, but it's divided up exactly into 2 equal parts. So this part is always equal to this part. This part is equal to this part. Okay, so let's see what we have here. Let's see what we got for our points. Now we can see visually this looks pretty good. Let's see what our points are. So we knew that negative 1, 1 went to 1, negative 1. We know that the y, which is negative 3, 4, went to 4, negative 3. And we know that x, oh, I think I did it wrong. I put my y and my z in the wrong place. So let me wipe that out and fix that. Sorry about that. That is the point. That's the coordinates for z. Z is the negative 1, is the 1, negative 1. X is over here, and for x, our negative 5, negative 2 went to negative 2, negative 5. Okay, so now let's think about this. Look at our original points, look at our new points, and we are going to now see a rule for the third of the big four. These are the big four lines. A reflection in the line y equals x. Believe it or not, this one is one of the most important ones because of what you're going to learn, and you might have already learned a little bit about inverses. And inverses are when you switch x and y, and that happens when you reflect x over y. And the rule for these is that xy is going to go to yx. Okay, look at it. Negative 5, negative 2, negative 2, negative 5. Negative 3, 4, 4, negative 3. The signs didn't change, right? What was negative remained negative. So this is different from the other reflections. The only thing that changed is that they moved to the other side. The x's turn into y's, and the y's turn into x's. So if you have an xy, you're just going to switch the coordinates, and that's how you're going to get your reflection over the line y equals x. Okay, pretty cool. Let's look at, let's highlight this to make sure we know when you're looking at your notes later. And remember, this page is your notes. You're going to look for those highlights and find those ones that are the main rules. And now the last of the big four, this is just practice. You guys can do that practice later. The last of the big four, right here, reflecting over the line y equals negative x. So we're going to do the same thing. We're going to plot these 4 points that make up a square this time. We're going to plot the square, and we're going to plot the line y equals negative x, which just goes the opposite corners here. It just goes the other way. Okay? Okay, so there's my square, A, B, C, D. Here's my line, y equals negative x, right there. And now we're going to do the reflection. Now, I'm going to say the points because I know the rule. This one's a little bit harder to see. So actually what I'm going to do is I'm going to write down the reflection rule first. So reflection in the line y equals negative x, y equals negative x, is going to be xy. Now here's how you can remember this really easily. So far what we've had is we've had a reflection in the x-axis which switched our x, y to x, negative y. So we made the y's negative. Later we did one where we made the x's negative. And then most recently we did one where we switched where they are, right? Well, this does absolutely all of that. So it's going to make both negative and switch where they are. So x will come to the second spot, y will come to the first spot, and they'll both become the opposite of whatever they started with. So this would be the opposite of y and the opposite, of x. Okay? So let's look at our points. So I'm going to actually put the points here right next to it so we can see how to apply the rule. And we'll focus on the points before we actually focus on the graph this time. Alright, so the point A was at negative 1, 3. The point B was at 0, 6. The point C was at 3, 5. And the point D was at 2, 2. Let's apply the rule. Alright, so negative 1, 3. Well, let's see. The 3 has to move to the beginning, and since it starts positive, now it's going to be negative. So this is y. This is the opposite of y, would be negative 3. The 1, which was the x, is now going to move to the other side, and it's going to be the opposite sign, which is positive. It turns from negative to positive. All right? The 0 comes over here. You can't change 0 from negative to positive. It's neither. But the 6, which is positive, comes over here and is negative. The 3 is positive, moves over here and becomes negative. The The 5 is positive, moves over here and becomes negative. Then the 2's just both become, they switch and become negative, but you can't really tell that they're switching because they're the same number. All right, there's our points. Let's plot them and see if we get the reflection. So I'm going to plot those points. You do the same, and we'll see how they look. Okay, and there they are. These are just the coordinates that we already found here using the rule. We did this one backwards. We looked at the rule first, and that is our 4th important rule. So let's highlight that or box that in so we can remember that. And then it's just a matter of connecting and shading this, which I'm going to do right now. Okay, so we saw 4 rules, and the 2 that you really need to make sure that you know are these 2, because they're kind of hard to do just from looking, because the line is oblique. The line is not horizontal or vertical, so it's a little bit harder to follow these lines and see exactly where they go. So we have the rule that says if you're reflecting over x, y, you just switch x and y. If you're reflecting over x equals negative y or y equals negative x, then you switch them and you also change them both to the opposite sign. Okay, the other 2 that you're going to do is, I'm just going to show you right here and talk about them a little bit. So first, you're going to do reflections over vertical lines other than the y-axis. So we've already done the y-axis, but without the y-axis, we can still do these. And all I did here was recognize, first of all, you do need to know that the line x equals 4 looks like that. It's a vertical line. I plotted the pre-image points here, and then you just count to the other side of the line. So if this was 1 unit to the left, its reflection will be 1 unit to the right. If this one is exactly 2 units to the left, its reflection is exactly 2 units to the right. And once you get your point, same thing with j. J is actually 1, 2, 3 units to the left, so we have to go 1, 2, 3 units to the right. And then just plot the points. Okay, and then the last case will be when you have a horizontal line like y equals 2, and here's the line y equals 2, that's horizontal. It's just like the problem that we did with the x-axis, except we're not going to use a rule. We're just going to use that counting method just like we just saw. So if you have the original pre-image plotted, this is 1 point below, so you just need to make E prime 1 point above. Okay, here, this F was 1, 2, 3, 4, 5 units below the line of reflection. So we go 1, 2, 3, 4, 5 units above the line of reflection. And so on with all of these. And once we get the points, we just carefully figure out if we look at the graph and figure out what the ordered pair is for all of the primed points or the image points. Okay, that's pretty much all we're going to do with reflections in the coordinate plane. I hope you found this video helpful.